Next, we'll discuss the port latches. Here, the port 0 latch is shown. Likewise, in the architecture, there are three another latches. Those are nothing but P1, P2, P3. The port 0, 1, 2 and 3 has the latch P0, P1, P2, P3 respectively. Port pins can be configured as input or output. Logic 1 must be returned to the corresponding latches by the instructions in program so that the particular port acts as an input port. Also, a logic 0 must be returned to the corresponding latches by the instructions in program so that the particular port acts as an output port. Upon reset and power on, all the port bits are set to 1, which means that all appropriate pins will be configured as inputs. So if this port 0 is to be configured as the input port, then the content FFH must be stored in port 0, so that the data 1111 will be stored in all these locations from bit 0 to bit 7, and all the pins of port 0 will act as input. Similarly, if this port 0 is to be configured as output port, then the data 00H must be stored in this latch. That is, all the bits from 0 to 7 must be set to 0 or must be cleared so that this port will act as an output port. Another important register is program counter. This is a 16-bit register which is used to hold the address of an instruction byte in program memory. Program ROM may be on chip at addresses in the range from 0000H to 0FFFH. External to the chip for addresses that exceeds 0FFFH, or totally external for all addresses in the range from 0000H to FFFFH. The program counter is automatically incremented after every instruction byte is fetched and may also be altered by certain instructions. The PC is the only register that does not have an internal address. We have seen all these details in the programming model of 8051 also. The remaining SFRs of the 8051 are listed here. Very first is the interrupt enable and interrupt priority, IE and IP. Those are covered in the next section, that is interrupt structure and response. These two SFRs are related with the interrupt structure and response. Then comes the SFRs like TMOD, TCON, TL0, TH0, TL1 and TH1. All of them are related with the timer counter operation, and those will be covered in the unit 6. Similarly, the SFRs such as SCON, SPUF and TCON are related with the serial communication, and they also will be covered in the next unit, that is unit 6. So far we have discussed on-chip data memory. The on-chip data memory, which is having the address range from 00H to FFH. 00H to 7FH is nothing but the 128 bytes of internal RAM, and further 80H to FFH, certain locations are nothing but the SFRs. Now we will discuss the on-chip program memory. The 8051 is organized so that data memory and program memory can be in two entirely different physical memory entities. We have seen that on the in the block diagram of 8051, there is on-chip ROM of size 4K and the on-chip RAM of size 128 bytes plus the SFRs. The internal ROM is of size 4K. So obviously the address range for it will be 0000H to 0FFFH. A program counter is a 16-bit register which is used to generate addresses in this range, so that a particular location in ROM is accessed and the required byte is fetched from the memory as an instruction. Thus, the addresses which are above this range, that is above 0FFH, will cause 8051 to automatically fetch the code bytes from the external ROM. Code bytes can also be fetched exclusively from the external memory by connecting the external access pin, that is EA bar, to the ground. Now we will discuss the external data and program memory. The interface of external data and program memory is as shown in this figure. You can observe in this figure, it is for the microcontroller 8031, which belongs to the family of 8051 only. Here there is a latch, 373 latch, which carries out the separation of address and data. Then here it is a 16K EEPROM, the IC number is 27128, and here it is a 8K RAM, which is nothing but 6264. Two separate external memory spaces, RAM for data and ROM for program, are made available by the 16-bit program counter and data pointer, and different control pins for enabling external ROM and RAM chips. Internal control circuitry assesses the correct physical memory depending on the machine cycle state and the instruction being executed. The 8051 has 128 bytes of internal RAM and 4 kilobytes of internal ROM. If the program is written in high-level language, its size exceeds 4K, then an external ROM is needed. As program counter is a 16-bit register, the total program memory, internal and external, can be as large as 64 kilobytes. External RAM, which is accessed by DPTR, that is data pointer, may also be needed whenever 128 bytes of internal data storage is insufficient. External RAM up to 64K may also be added to 8051. Figure here shows the connections between 8051 or 8031 and an external memory configuration consisting of 16K of EEPROM and 8K of static RAM. The 8051 accesses external memory whenever certain program instructions are executed. External ROM is accessed whenever the EA bar pin is connected to ground or when the PC contains an address higher than the last address of internal 4K ROM, that is 0FFFH. The 8051 thus uses the internal and external ROM automatically. The ROM may be expanded to 645K by using 27512 type EEPROM and connecting the remaining upper address port lines A14 and A15 to the chip. SRAM capacity may be expanded to 64K by using a 62864 type chip. Port 0 is used for lower address byte and data. Port 2 is used for upper address byte. Also, the read bar and write bar signals are used for data transfer, which are the pins of port 3. Thus, the use of external memory consumes many of the port pins, leaving only port 1 and port 3 for general input-output.